Assalamualaikum and good day, student. This is lecture 8, chapter 2, tutorial 1 under Kinetics of Particle, mainly focus on the work and energy. This is example number 1. Like say there is a 10 kilogram block. You letakkan dekat satu inclined plane with a degree of 30 degree, and then it being pushed horizontally for about 400 Newton, and then the plate actually by pushing at 400 Newton sebanyak 2 meter. So dia tolak blok ni naik ke atas sebanyak 2 meter. Tapi sebelum dia tolak tu, those spring is actually telah stretch sebanyak 0.5 meter. So before the 400 Newton external forces is being applied to the block which is attached to the spring, there is an original the spring is been facing stretching position about 0.5 meter. So what we have here is actually we need to consider a few work that involved in this situation. Number one is related to the forces, external forces, work due to external forces along the plane, and then work done by the spring, and then number 3 is the work done by the weight of the block itself. This is due to the expansion of the spring. External force is because of there is external force is being involved in this situation. Weight is due to the block is given a certain masses, is about 10 kilogram. So I can say that the total work done, I put it here, is UT, total work done, is actually U due to the external forces plus work done due to spring compression or expansion, and then work done due to weight of the block. So let's see on the first work done by the external forces. If we break the because the block is moving in this direction, so we are considering this plane is the plane that the block is moved in this direction. So at the same time, we need to break the external forces into according to the plane. Like say this is the axis of X and Y. So we know that the degree is 30, so this could be 400 cos theta. Just now I put the work done by the external forces is UEF. So actually work done, if there is external forces, is F times S. So the distance, the forces is actually 400 cos theta, and then the distance is this one, 2 meter. So it's times 2, and then we get the answer is 962.8 joule. Oops, sorry, it's actually equal to 692.8 joule. Okay, what about the work done due to spring? I just now put the work done by the spring is US. So as you know, negative 1K coefficient is given by 30 Newton per meter, and then S is the distance of 2 squared minus S1, sorry, this is S1 squared. Okay, the idea is actually the question is giving already give you saying that in initial position, when before the external forces is being applied, so actually there is expansion of the spring about 0.5 meter. So this have to take into consideration, because before the spring or the block is being introduced by external forces about 400, originally the block is been the spring is been elongate about 0.5 meter. So what we will have here is work done on the spring is equal to negative 1. K is 30, and then S2 is position, taking the position from the initial position. So this is the initial position. So this is S2, this is S1. So S2 is being taken from this direction. So mean S2 is 2.5 squared minus S1. S1 is being measured from this position, from this line. So S1 is 0.5 squared. Then you will get the answer minus 90 joule for the spring work. So this is work 1, this is work 2. So another one is work due to weight, which is since the block is being moved from bottom to top, so the work is negative, so it is delta H, where M is 10 is it 10? Yeah, 10 kilogram, and then 9.81, and delta H we are referring to this one, because this is where the effective force due to weight. Okay, so this is 2 sine 30, 2 meter sine 30. Then you will get the answer is how much? 98.1 joule. So the total work done, UT, is actually U, I say UEF as due to external forces, plus U spring, plus U weight, which is 962.8 minus 90 minus 98.1. So we will have the answer of 504.7 joule. So the total work done to bring the block up in a slanting position is about 408.7 joule. Okay, just now, if you remember, I break down the external forces into this plane component is equal to 400 cos theta, and then this one is actually 400 sin theta. So the work done is happen only if the block is in the same direction with the external forces. What about the external forces at this direction? So this external force 400 sin theta directing to the in this direction will not bring any movement or motion at the axis perpendicular to the plane, to the inclined plane. So that's why this is not take into consideration. Only force, external force acting at the same direction of the block is been taken into consideration to generate to reveal the external forces, so to reveal the work done due to the external forces. So this is the final answer.